All right, let's jump right into it. Welcome to today's explainer. If you're a developer gearing up for technical interviews, or really just someone looking to write significantly faster, more efficient code, you are in the exact right spot. Today, we're unpacking a total game changer in data structures and algorithms, the two pointers technique. I absolutely love this concept because honestly, it takes these overwhelmingly complex problems and elegantly crushes them down into simple, manageable logic. It's so satisfying to use. So get comfortable, focus in, and let's unravel this together. 30. Now, why is that number so important? Well, in the super competitive world of coding interviews, efficiency is literally everything. And mastering this single conceptual framework we're going over today, it gives you the blueprint to solve at least 30 distinct LeetCode problems. Just think about the return on investment there. By nailing this one single concept, you're instantly equipping yourself with the cheat code to unlock dozens of potential interview questions. It is absolutely the ultimate high-leverage skill. Okay, let's dive into this and look at the actual performance difference. A clunky brute force approach, like a nested loop, that gives you an O of n squared time complexity. And sure, it works, but as your data scales up, it just grinds to an agonizing halt. It's the kind of solution that gets a polite nod from an interviewer, but rarely a job offer. But the sleek, fast, two-pointers approach, that operates in O of n time. By using two distinct indices to smartly scan an array, you literally drop an entire dimension of complexity. You're going from O of n squared straight down to O of n. Imagine the sheer relief in the interview room when you drop that kind of algorithmic efficiency on the whiteboard. To make this super easy to digest, this technique breaks down into three distinct patterns, starting with pattern 1, opposite ends. The mechanical simplicity here is just fascinating. In the opposite ends pattern, you establish your two pointers at the absolute extremes of your array. So you start your left index at 0 and your right index way over at n-1, the very end. Then, step by step, you move them toward each other. But, and this is key, you don't just move them randomly. You step inward based on a specific logical condition. They march toward the center, evaluating the data as they go until they finally meet. It's highly structured and incredibly efficient. And this brilliantly illustrates the concept in action. Take the classic two-sum problem in a sorted array. You're looking for two numbers that add up to a specific target, right? Because the array is sorted, your pointers give you total control. If the value at your left pointer plus the value at your right pointer is greater than your target, what do? Well, you need a smaller sum. So you shift your right pointer to the left, pointing to a smaller number. And if the sum is less than your target, you need a bigger sum. So you bump your left pointer to the right. It's like you're literally just turning dials to tune right into the exact answer, all in a single pass. Moving on from pointers coming toward each other, let's look at pattern 2, same direction. You might actually know this one as the famous slow and fast pointer technique. In this variation, both pointers start at the exact same place and travel in exact same direction. But here's the catch, they travel at different speeds. Your fast pointer acts as a scout, scanning forward through the array and looking at new data. Your slow pointer, on the other hand, is your record keeper. It tracks the current right position. This dynamic is absolutely perfect for problems where you need to modify an array right there in place, like when you're removing duplicates. The fast pointer finds those unique values, and the slow pointer writes them down, marching right behind it. And that brings us to our third and final variant. Pattern 3, the sliding window. The sliding window is actually a specific, super powerful variant of the same direction pattern. Here, both pointers are moving right at different speeds, but their primary purpose is to maintain a continuous subset, or a window, of data between them. You expand that window by moving the right pointer to include more data, and you shrink the window by pulling the left pointer forward to exclude data whenever a certain condition gets broken. It is just a fantastic way to scan through contiguous subarrays without constantly recalculating overlapping elements. Now, before you run off and apply these, there is a massive trap you need to avoid. So let's talk about the crucial golden rule. So the crucial point is this: sorted or monotonic. The key insight here from our source material is that the two pointers technique relies heavily on predictability. I mean, you can only know which pointer to move, left or right, fast or slow, if the underlying data actually has a predictable structure. Therefore, the array must be sorted, or you must be maintaining a monotonic condition. If you get an array problem in an interview and you immediately think, two pointers, pause. Always clarify with your interviewer if the array is sorted before you apply this. Asking that one simple clarifying question demonstrates immense seniority and attention to detail. All right, we have the theory and the golden rule down.
Next up, your practice roadmap to master these patterns.
To really get this into your coding fingers, our source provides the perfect trifecta of problems to test your new knowledge. You don't need to go tackle all 30 immediately, just start right here. Number 1, valid palindrome. Number 2, container with most water. And number 3, threesome. Now why these specific 3? Because combined, they perfectly cover every single variation we just explored. If you can confidently code the solutions to these 3 problems, you have functionally mastered the 2-pointers technique. You'll have built the exact muscle memory required to adapt to those other 27 problems with total ease.
So I leave you with this question. Which problem will you crush first? Are you going to start with valid palindrome to master the opposite ends pattern? Or maybe jump straight into the deep end with threesome? Whatever you choose, grab your favorite code editor and start building that O of N efficiency right now. Thank you so much for joining me for this explainer. I really hope this breakdown has completely demystified the 2-pointers technique for you. Keep learning, keep optimizing, and I will see you in the next one.